Hello. So we're going to talk a little bit about switches and primarily about electronic switches. So in order to understand this, the first thing we have to do is look at an ideal switch, which would be kind of like a mechanical switch. So first of all, we start with a voltage source with a resistor. Okay, and so what we're going to do is we're going to come over here and we're going to add in a switch. And so the switch has a current and a voltage across it. Okay, so the first thing, and we want to look at the voltage current relationship. So if this is my current and this is my voltage. Let's start with an open switch. So with an open switch, I can have any voltage across it, but no current. Okay, now if my voltage goes negative, so let's say that I'm going to come in here and take this and move it down here instead. So now we're basically going like this. So now we see that the voltage across it is negative. So what that's going to do is that's going to create this part right here. Okay, so now if I come in here and I close the switch. So now if my switch is closed, in this case, my current is going up. So you see that my voltage source is down here, so my current is going up. So that's negative, so that's this part right here, but it's a closed switch, so there's no voltage across it. Okay, similarly, I can take this and move this back up here. Move my ground back down here. And then in that case, you see, then I have the positive current right here. So you see we have these four quadrants. So right here, this is positive voltage, zero current, negative voltage, zero current. And then I have positive current, but no voltage, and negative current and no voltage. Okay, so this would be an ideal, what's called a four-quadrant switch. Okay, so now let's go look at our semiconductor switches. So let's start with a diode. So a diode, again, has a current, and it has a voltage across it, and then I can put like a voltage source, just like we did before. Okay, so now let's look at the way that this works in terms of the current voltage relationship for a diode. So now if my voltage across here is positive, I'm going to get current flowing, or if the current is flowing down, the diode is forward biased, and I'm going to get current along this axis. Now I can never have current flowing this opposite direction. So you can kind of see that I can't use this quadrant down here. Okay, so now if it's reverse biased, then I can be in this section right here. So if I have a reverse bias, but if I try and go over to this section, if I put a forward voltage across it, I can't hold it off. So you see that this part is X'd. So this is my diode. So it is a two-quadrant system. My current can only flow to one direction, and it can only hold off a voltage in one direction. Okay, so this is my first switch. Now we want to look at our MOSFET, which is our main switching device that we're going to be using. So here is what our N-type MOSFET looks like. And we're going to ground this, and this is going to be my control voltage. Okay, and then we're going to come in here and put a voltage source and a resistor. Now lots of times in LT Spice we're going to put a little resistor. So if this is like 10 ohms and this is 1 milliohm, this one's just to measure the direction. So, and then let's just do like 20 volts up here. Okay, or just our power supply voltage. And so you see that if VC is, and we want to look at our relationship of voltage and current. Okay, so if VC, so let's start with this control voltage. If the control voltage is high, this acts like a switch and I get current going down, and that current going down is a function of this DC supply. So the bigger my DC supply is, if VC is on, I can conduct current. Okay, and then if VC is low, so if VC is low, this becomes an open circuit, and I can have any positive voltage, and it will hold that off. So that is when it's off. Okay, but now we want to look at these other two configurations. So let's go over to LT Spice and take a look at that. So again, we start like this. If this is low and this is the voltage, I run this, you see that I get no current, and the voltage that I get is a function of this voltage. So I change this voltage, and that goes up and down. Similarly, if I turn this on, let's just say 10 volts, now I get lots of current, and the voltage here is basically 0. So now what we want to do is look at the other cases. So I'm going to make this minus 20. So if this is minus 20 and this is on, you see I'm getting current. Okay, so I can get the current, and which way? This one's negative, so my current's actually flowing up. So by changing this, if this is on, then my current flows up, and what is my voltage? So my voltage is basically 0 when this is on. So going back over there, that is this piece right here, where there's no voltage on. So now we want to go and we just want to turn it off, and I make minus 10 volts because this should be a nice switch. This should be off, and I run this and we get current. Well, so my transistor, my gate to source voltage is less than 0, less than the threshold. We shouldn't have anything on there. Let's look at what the voltage is. Oh, it's 0.7 volts. Okay, so what happens is that I can't turn it off if it's in this reverse configuration. So basically what happens is, let's just copy this over. And what happens is that built in, there is a what's called a body diode that looks like that. Okay, so if I try and block it, okay, then it's going to flow through the diode. Okay, so then I can never block negative voltages. So you see that I can't do this state. Okay, if I ever try to turn off a negative voltage, the current's going to flow anyways because it is just a straight diode going this direction. Okay, so in general, because of this diode, I always want to make sure that my voltage is positive. So I always want to keep my current flowing down. So most of the time, we try to avoid this state as well because that isn't a controlled state. The current can always flow that direction. If my voltage ever goes negative, my current's going to flow in the opposite direction because of this built-in body diode. Okay, so really we can see that what we really have is we really have this. Okay, so this is a diode where it just passively controls based on voltage, and this one is where I can control whether I have a positive voltage or a positive current depending on my control voltage, where I can turn it on and off and I get the control. But I need to make sure that for an NMOS, I'm always driving current this direction and my voltage is always positive. Okay, now how does this work if I have a P-type MOSFET? So for a P-type MOSFET, it's just everything is the opposite direction. And now you see that my current is driving from the source to the drain. And that's why we tend to flip it over here, where for my N-type, my current is always drain to source. Okay. And this one always has a negative voltage if my voltage is applied this direction. Okay, so you see that I could use an N-type MOSFET if I want negative currents and negative voltage relative to the drain to source. But we always want to go drain to source for an N-type and source to drain for a P-type. And then I can create my one quadrant switch with a MOSFET.